presenter is Jeff Morris, who is our learning content developer here at Ascent. So with that, Jeff, I'd like to hand the floor over to you.
Okay, thank you, Lori. I want to welcome everyone to the second part of this using the AEC collection tools for a fictional land development project. The first part was done back in January the 22nd, and it dealt with primarily with InfraWorks, using InfraWorks as a planning and visualization tool. For those that attended last month, please bear with me for the next few slides. They will be duplicated while I introduce myself and the topics to be covered. Thank you. Okay, so this is me, Jeff Morris, and I started with AutoCAD version 2.52, which was a short-lived release and soon got replaced with version 2.6. After that, they switched to release numbers rather than versions, and with release 9 also came DCA engineering software. And DCA engineering software morphed into ADCAD, Sofdesk Civil, Land Desktop, Land Development Desktop, etc. And the rest is history, leading us to the here and now. So my career has been divided between the buildings and the infrastructure sector, between working with Autodesk resellers and in Canada and the US, as well as a CAD and BIM manager for large and small firms in both the public and the private sectors, from a five-person civil survey firm to a prestigious interiors architectural firm in Philadelphia, to the Federal Public Works Department of Canada, to one of the largest AE firms in the Middle East. And now I'm working with Ascent, the Center for Technical Knowledge, developing learning content for our infrastructure and BIM 360 books, as well as Navisworks. We also develop custom content on demand. So with such a background in CAD and BIM management, my focus, my passion, really is to deliver all of these interesting tools that we have in the AEC collections in such a way to make your end product easier, smarter, and more efficient to come by, whatever your end product may be. Last month, we looked at the sketchbook and the Format programs to develop some sketches. And then we used InfraWorks to conceptualize these ideas and to do some preliminary layouts and grading. Today, we'll bring the InfraWorks model that we created last month into Civil 3D for further study and design development. And once the grading around the buildings is established, it can be shared with Revit. And finally, we'll examine both the Civil 3D, Revit, and the InfraWorks models in Navisworks for some visualization and quantification. Whereas InfraWorks, it was a nice conceptual visualization tool, for me, Civil 3D is primarily a design development, detail design tool. And we will be importing the InfraWorks model that we generated last month, the topology that we generated within that, as well as the corridors and surfaces directly into Civil 3D. We'll be referencing other sources, such as GIS sources. A little caveat here, there is a very nice tool both within InfraWorks and Civil 3D, the ArcGIS connector, but I won't be using that. I didn't use it last month, and I'm not going to be using it in Civil 3D. We will be incorporating the sketch that we generated last month, as well as CAD and Revit so-called drawings, which are DWGs that were exported from Revit. The Format FBX file that we could use for Format is no longer supported as an import in Civil 3D. We'll be looking at design options within Civil 3D by utilizing data shortcuts and swapping out different data shortcuts for different options. We'll be looking at different sites. We'll be managing the XREF through various layer states. And then finally, in preparation for Revit, we'll be producing a shared reference point that Revit can read. And then we'll be publishing our surface within Civil 3D to BIM 360, which then can be linked into the Revit file. So to look at this in a little bit more detail, we will first be importing the proposal of InfraWorks directly into Civil 3D without any major rework. We'll be XREFing in the 2D Revit footprint into our Civil 3D site plan. We'll be using Raster Design to incorporate the sketch that I generated last month. We'll be setting up an XML file for shared coordinates to be imported into Revit later on. And then we'll be swapping out data shortcuts through the Data Shortcut Manager to look at various design options to see how they fit within our overall design. We'll be using Civil 3D sites for additional layout options. And then finally, we'll be publishing the surfaces that we generate in Civil 3D into BIM 360 that can then be incorporated into Revit. This is a pre-recorded video. And I start with a template. Since I do most of my work in a particular fictional geographical area, I already have my template set up to that particular coordinate system. And I have this little README file in the middle of my drawing stating the coordinate system it's at. And if you need to have another coordinate system, go to Drawing Settings to change your coordinate system. And please delete this message. It will not self-destruct in 5 seconds. Okay, so I'll delete this message. And now I'm going to insert my InfraWorks model. And I browse out to my local cache of that InfraWorks model, which is in your Documents files under Autodesk InfraWorks. And you see that the coordinate system that was done in InfraWorks is compatible with the coordinate system that was in my template drawing. So I don't need to change my coordinate system within this drawing. Rather than bringing the entire InfraWorks model, I'm going to select the area that I want to import via Window. And it brings in the same Bing Maps file that we had in InfraWorks, so we can see the area that we want to import. And now that I've limited the area that I want to import, I can also refine my selection set by selecting the InfraWorks objects that I do want to bring in. I don't want to bring in the planning roads. Those are the roads that InfraWorks generates automatically from the model builder. I do want to bring in the component roads, which will be converted into Civil 3D corridors. And the surfaces, I don't want to bring in the existing transportation surface. That is the surface that gets draped over the planning roads, which is basically already your existing surface. So I'm just bringing in my component roads and my existing ground and my proposed ground that I generated last month with the grading. And then I open the model. It takes a little while to import that. And now I no longer need the Bing Maps, so I go to my geolocation tab to turn off my Bing Maps. Now what I'm going to do is I'm going to save this into my surfaces reference file as IWX surface. And we have our data shortcuts already set up. So within this drawing, I'm going to create data shortcuts for the InfraWorks surfaces, my existing ground, and my final ground. Now, after I did that, I'm going to do another Save As, and I'm going to save this now in my working folder. Now, this may seem a little bit strange, but bear with me what I'm doing, and hopefully, eventually, it'll make sense. Because in my work, this is now going to become my working drawing. I'm going to call it Concept A. Because I want to have ultimate flexibility in the surfaces that I want to swap in and out. And for that reason, I'm going to now rename the surfaces to simply EG for my existing ground and FG for my proposed ground. And then I'm going to go to my Manage Data Shortcuts, and I'm going to link my existing ground to my InfraWorks surface. Make sure to click the link button in between, and also my final ground to my InfraWorks finished ground surface, and I'm going to link that. So once again, the reason I'm doing that is later on as we get into more design alternatives, I can go to my Data Shortcut Manager and simply swap out other surfaces that I may have into EG and FG, and the dynamic relationships within Civil 3D will be maintained with these different surface options. Okay. So as I did last month within InfraWorks, I did a slope analysis. We did a slope analysis, a aspect analysis, and we also did a variety of earthworks calculations. We're going to be doing the same thing within Civil 3D. We're going to start our slope analysis. The 4 ranges are already set up from going from 5 to 30%, and I duplicated the colors that I had in InfraWorks. I go over and I set my style to the slope style, and it does the analysis on that. And very similarly, I can do the aspect ratio like I did last month, again with the same steps that I did earlier. And for my earthworks, I'm going to go to my Analyze tab, my Volumes dashboard, and I need to create a new volume surface. Call it Site Volumes. And I'm going to compare my existing ground, EG, with my finished ground, FG. And it calculates the volume between the two. Now with that site volume surface that I have, I can do another range analysis, and it's going to show me where my cuts and my fills are. And the deeper the cuts, the deeper the red, and the same for the greens. Now in InfraWorks, the volumes were all these, a tooltip, and I had to write these down. With Civil 3D, we can make these permanent by producing tables. I'm going to go to my add a table for my volume surface. It's a dynamic table, so as the surfaces change, my volumes will update. And I can also produce another table for my slopes that I have up above. I'm going to jump forward a little bit. In InfraWorks, we had these bookmarks, so we could quickly go back to the particular area that we want to work with. We can duplicate the same with Civil 3D via AutoCAD by producing a variety of views. So I'm zooming into the area that I want, and I'm going to create a view for this and call it Plan. Go to my View Manager, create a new view for Plan, And be careful of the layer snapshots. It's kind of a double-edged sword with the functionality of that. Sometimes it can mess you up. Now I'm going to attach my XREF, very similar to as I did last month within InfraWorks, of my proposed engineering. That XREF was georeferenced, so I selected, it came directly at 0, 0, rotation angle 0, and it fell right into place. I'm bringing in my sketch that I generated last month with the Sketchpad program, like I did with InfraWorks. And I'm utilizing raster design for this tool. So I select via my desktop connector. I go into BIM 360 via my desktop connector and select the image that I want to bring in. I'm using my insertion dialog box. And I'm going to pick my insertion point and roughly give it the scale that I want. Last month within InfraWorks, we could place by reference point, and we could have up to 3 reference points so that we could reference the image to the model up to 3 points. Within raster design, we have 2 options. We have the rubber sheeting, which allows us to rubber sheet with as many reference points that you want, or we have the match that will allow us to have 2 reference points. So in this case, I'm going to use the match command. And I select the point within my image as well, and then I tell it which point that should coincide with the model. Now, with the match command, I can do that up to two times. Now I want to place another XREF, and this is the 2D footprint of my Revit hotel and my Revit school. In this case, I need to specify my insertion point and my rotation. And I'm not too, I kind of eyeball where it should be and eyeball with the rotation angle. And I'll be using the align command, the AutoCAD align command later on to bring it into place. Now you also notice that I have different DWGs, Hotel 2D and Hotel 3D, Office 2D and Office 3D, so that I can swap my 2D footprint into a 3D model for visualization later on. So we're going to be bringing in the school now. So with the school, I place it into place, and I kind of eyeballed with the rotation. Later on, I'll be using the align tool to finish that up. With the school, even though it says it's 1:1, that my base unit is feet, it's actually not, and I have to scale it down by 12. And when I select my insertion point, the crucial part is that I use my nearest and I select the contour. So it brings it near at that contour elevation. And once again, I position it properly as best as I can, and I'll be using the align tool later on. The align tool is not at all like the Revit align tool. It's, but in some ways just as powerful. It allows me to pick 2 or 3 points similar to what I did with my match. And I select my destination point. And what I do with the align command, I use the .xy filter a lot. And what that does is the point that I pick for my destination point, I type in .xy, and then it reads the x and the y coordinate of the point I pick, and then it looks for the z or the z or the elevation. And I type in the at symbol, to designate that the elevation is the same as the source point that I picked. So therefore, it holds the elevation, but it moves the XREF in the X and the Y, holding the elevation. And I'll do the same thing later on with the for my shared reference point when I give it the quasi-north point. I use the XY filter again. So I'm using the align command. No. Before that, I'm going to process this image. It's a little bit too strong, so I select the image, and within the histogram, I can adjust the tones of the image, and I can see the preview as to how it's going to be adjusted. So now the image isn't near as strong as it used to be. But on second thought, I don't even want to see the image. What I like about raster design is I can have multiple images and simply select the image that I want to load or unload or edit with the pull down. Last week, here's where we're going to be using the align command. So, and this is where I use the .xy filter when it needs the Z. And after I give it 2 points with the align command, I have the option of giving it a third point, and that would actually rotate it in 3D. If I don't need to rotate it in the 3D, I say no, I don't want to specify the third point. And then it asks me if I want to scale the objects based on the 2 points. And again, I can say yes or no. In this case, I said no, I don't want to scale the object. Last month, we turned off the contours to my visualization style. We have the same options within Civil 3D by changing the style of my existing ground to no display, and the contours turn off. Now it's time to generate the shared reference point. So I go to my toolbox and execute my shared reference point. It's looking for the base point of my building. So I select my base point, and here again I use my .xy filter that is also accessible through my right-click menu. Here's my .xy, select that point as my quasi-north, and again I put the @ symbol in. I verify the elevations and that this is in feet, and then I browse out, it already goes up to BIM 360 for the shared reference point XML file. Now with regard to the school, the hotel, we have 2 different options, and I have 2 different layers, building footprint and building footprint B. Both XREFs are in there, and they're on different layers. So simply by sawing and freezing a layer, I can look at the different options available to me. I'm going to saw my building footprint B and freeze my building footprint. And I'm going to execute my shared reference point again by selecting my base point, my quasi-north point. Again, I give it the elevations. And in this case, you notice that I picked the wrong point. So you see that the Z elevation is actually 14. So I'll need to redo that. So always keep an eye on this select units to see that the elevation is in the proper range. And again, I share it into BIM 360 via my desktop connector. It doesn't need to be shared in BIM 360. You could just simply email that to your client. Now we're going to generate a feature line for our preliminary grading. I select this XREF boundary as my feature line, and this is where we get into options. I kind of skim over this a little bit, but let me explain this a little bit more. The options within Civil 3D allow us to have the sites within Civil 3D allow us to work with multiple design options. And the sites will contain grading objects, parcels, some alignments if need be. And the nice thing about sites is that we can have all these different design options available to us, all within our grading and our parcels, etc. And then when we decide on a particular design option, that's when we first we'll need to archive the drawing, and then we can simply delete the sites that we no longer need, and all the alignments and feature lines and parcels and grading that belong to that site get eliminated in one fell swoop. So with proper management, it works quite well. But again, it can be kind of dangerous. I'll name this as a hotel. And the feature line, I want to read the elevation from my finished ground. And I'm going to set this relative to the finished ground 1 foot up. So as my finished ground changes, my feature line will change. Now with the grading, I finished the grading now, and I simply gave it a surface style so I can see my grading. So these are the 2 features with my grading. And now we're going to go fast forward here a little bit, and we have now different design options. And I can go, as I explained earlier, I can swap out my different existing site surface and my finished surface with FG. And so we can quite quickly see the different design options that are available to us by swapping out the different surfaces through our data shortcuts. Now we have some surveys that we can incorporate. They've already been processed. So I can simply right-click on the survey that I want and insert that into my drawing. And you see with a well-tempered survey database, we have the trees coming in at proper scales regarding the drip lines. And as I bring in my field book, insert that into the drawing, it comes with all the points and all the survey figures as well. Now it's time to publish our surfaces. We're going to publish our hotel surface. For this one, we do require BIM 360. And it goes directly through our desktop connector into the BIM 360 project. And we're publishing each surface to its own individual file. And we're going to update the surface style so we have better fidelity within Revit later on. I'm going to publish also my finished ground surface. It goes again into our BIM 360 hub via our desktop connector. And we're going to swap out our styles as well. Now, if you're quick enough, you can right-click on your system tray to see whatever your pending options will be within your desktop connector. Okay. So the next step is to go into Revit. And as we saw, we just produced these surfaces to go into Revit via the desktop connector. And if we have multiple Revit buildings, then we should create multiple surfaces, again, to have be as flexible as possible. So via BIM 360 and Revit, we go to link our topography. And the links within Revit of the topography, it becomes a new tab within the Manage Links. And I can load them, unload them, reload them, just like any other link within Revit. So within Revit, we're going to be creating the base point and our quasi-north point, very similar that we did in Civil 3D, to read those the coordinates and the elevations of that shared reference point that we generated. In Revit, we have also sites that are different than the Civil 3D sites. And we typically want to rotate our site plan to true north versus project north. And the level markers within Revit, they can either be project-based points, so they're relative to our ground level, or they can be survey elevations that would give us the sea level elevations. And then when we link our topology, Since we have the shared reference point, the topology falls right into place. Without the shared reference point, we need to manually place them. Again, this is a pre-recorded video, so wish me luck. So in Revit here, we have 3 tabs already set up, 3 drawing tabs set up. One shows a 3D, one is the east elevation of the building, and the site plan. So I'm going to go to my, first of all, since we're going to change our coordinates with it, it's probably wise to do a save as of this project and call it Modern Hotel Shared, just in case something happens. And here on my site plan, I'm going to go to my project, my properties, and change my orientation from Project North to True North and apply that. Nothing has happened yet because we haven't yet brought in any reference points. So we're going to bring in our shared reference file. And just like Civil 3D, I select my base point and my quasi-north point. In this case, I don't need to worry about the elevations. And I select the reference point from the BIM 360. It's just confirming that I do indeed want to create a new site for this. And again, nothing has happened. And I'm going to be bringing in Hotel B option as well. And again, the site plan doesn't yet reorient itself to True North because we haven't changed sites. So if I go to my Manage tab, I have my sites, and here are the 2 sites that I brought in, Hotel A and Hotel B. And I can make those current. And finally, our site plan orients to True North. This is Hotel, if we go over to Hotel A and make that current, again, the site plan oriented itself to that. And we also, now in our elevations markers, we see currently they are set to the project base point, so the ground level coincides with 0. My second floor is 18 feet up. And normally I would have 2 different level styles, one for survey and one for project base point. And also notice in the elevation, I as yet do not have any ground elevations. Ground pattern beneath my building because we don't have a surface here yet. But in this case, I'll show you how we can simply edit the type from project base point to survey base point rather than having 2 different styles. So I edit the type of my level marker and change it from project base point to survey base point, survey point. And now you see that the elevations change to sea level rather than project level. Now for our design options, we can do design options directly within Revit through our pull down at the bottom. We have 2 different alternatives for our entrance, and this is one alternative. I can go to the other alternative, and you see the rest of the Revit model is grayed out because this allows us to work on the different options. And if I set it back to main model, then the whole model is now editable. I'm going to link our topology now. It browses out to BIM 360, and I select my Hotel A. And because I have my shared reference point already in here, it falls directly into place. I'm going to also link my final ground, my full final ground as well. And again, through the shared reference points, it falls directly into place. Now we have 2 surfaces together here. To manage the surface, I could use my standard Revit tools by hiding that particular element and turning it off. Or another option, perhaps even more clever, is to manage our links. Here we see the topography tab that we have. These are the 2 surfaces, and I can simply unload that, or I could reload it from a different file. Now if I go to my elevations, now you see we have the ground pattern where the surface was. Nice little hatch pattern there for my Earth. Now that we do have our shared reference point, I can export this to Civil 3D. I have a view set up with my visibility graphics as to the elements that I want to incorporate in my Civil 3D export. And as we saw earlier, I'm going to have a 2D and a 3D survey drawing that I'm going to be exporting. So I go to Export to DWG. And one thing that you need to be careful of is in your options to make sure that under units and coordinates that we save it to the shared coordinate system. And it is here where we would also designate what the units are. This is where we screwed up with the school earlier, where we messed up the units. Okay, moving on to Navisworks. Navisworks is a great tool. There's a lot in it that the more I dig into Navisworks, the more I like it. It's a great integrator. It's going to take a whole bunch of different files together and bring them all together. But we're going to be looking at quantification and visualization. And you may know that Civil 3D has some pretty awesome quantification itself. It's got a whole QTO, quantity takeoff, for miscellaneous quantification. We can add materials to corridors and pipe networks, say gravel or asphalt or paint or concrete. And we saw how we can compute earthworks. Revit itself has some schedules for quantities and material takeoffs. So why do we do it in Navisworks? Because Navisworks can do a quantity takeoff of all of the models that it incorporates. So let's say that you bring in a Tekla model or a ArchiCAD model, Archibus model. And you do not have Archibus itself, but we can do the quantification directly here in Navisworks because it understands all the elements that it brings in. We can also do 2D linear takeoffs via DWFs that we bring in, or even virtual takeoffs in terms of placeholders for elements that aren't there. So with Navisworks, we're going to first consolidate the drawings and the Revit models, and even the InfraWorks and Format models via SBX we can bring into Navisworks. And since most of these are already georeferenced, they will fall directly into place. And once we bring them all into a Navisworks, once they're cached, Navisworks is very fast. For the quantification, we're going to be creating a workbook that consists of resources and items. And the resource catalog will consist of all the individual bits and pieces that we want to count. And the items will take all these little, these resources, these bits and pieces, and bring them into items. And then we can import our search sets definitions. And then we search for objects and we assign them to the items. And finally, we can export our quantification. In terms of rendering, we'll be looking at materials and material libraries. We're going to be placing some lighting and then adjusting the environmental settings. Okay, so within Navisworks here, we already incorporated everything. And if I go over to my sets pull down, we can actually see the different options that we have available to us. So this is my Civil 3D drawing. This is my elementary school, the buildings that we brought in from InfraWorks. I'm going to zoom in. And here we see the trees that we brought in from InfraWorks, as well as the city furniture that we produced last week. The nice thing about incorporating all these elements is the views that we generated in Civil 3D, as well as the views within Revit, they come across as I incorporate these models. So that makes it quite easily moving around. These are the views that I generated in Civil 3D, and these are the views that came in with the Revit models. I'm just going to go back out to my entire site plan. And now for quantification. I invoke my quantification tab, and I'm going to set up a new workbook, go to my project setup, and I'm going to import the resource and the item catalogs that I've already generated that might be standard for my office. So you see that in our quantification workbook, we have the various resources, which again are the little bits and pieces. And we have the items that are made up of these individual bits and pieces. And I broke them into a work breakdown schedule. And that is our overall quantification workbook. Now for my sets, I'm going to import the search sets that I had, which might be a standard office practice as well. I'm going to import my search sets. And the nice thing about these search sets is it simply, select all the walls who happen to be interior. And it finds all of these walls for the entire model. So not just for the school or the hotel, but all of them together. And then we simply right-click on those and add them all to that workbook. Now for 2D layouts, I can have different DWF files coming in, and I can use these different DWF files to perform a takeoff. I select the category that I want to take off, and then I can select either, so let's look for standard partitions, and I can select these lines. So it can either be an individual line, it can be polylines, it can be areas. And I select all the lines that I want to categorize for that particular wall. I can also do counts. So for example, individual doors. So I select my door, a single door, and I start putting markers here where I want to count my doors. So this is a door, this is a door. Now it's not perfect. I'm going to select this double door as a single door, so human error can still come in. The nice thing about this is it's going to add all of this up for us. And when I save my DWF file, when I save this Navisworks file, it knows how much I've already counted, so that next time around these dots and these lines are already there. So I don't need to reinvent the wheel. Now for virtual takeoffs, let's say that there's going to be a door here. I know that a door needs to go here. So I'm simply going to create a viewport within Navisworks and tell it that we need to add a door. I go to my quantification workbook and I go to my virtual takeoffs. And I'm going to select what type of door it's going to be. And I'm going to add this as my virtual takeoff in terms of a viewport. And then when the door actually gets generated, I can move the door from my virtual takeoff to my quantity takeoff. Now I can also show the objects that I've already taken off or hide my takeoff quantities, objects. And at any point, I can export this to my Excel spreadsheet. Save that in my project folder. And opens up my spreadsheet with the quantities that I have so far. So it's all very efficient and quite user-friendly, especially if you start using predefined objects criteria. Now for my rendering, within my rendering, I have my materials that I can use. I have 4 tabs along the top for my materials, my mapping, my lighting, my environment, and the settings tab, of course. So I'm going to go to a predefined view for my school exterior. And I select the object that I want to apply a material to. And then I'm going to search for the material that I want to apply for that. Let's say a grass. And I select the type of grass that I want, right-click, and assign it to my selection. Now for this parapet up here, I'm going to select one object, and then I can have Navisworks look for all of the same type, and it finds all the parapets. Again, I'm going to search for brass and assign brass to all of those parapets. We can go even further. So I'm going to select one sample material and tell it to search for all of the Revit materials within the entire model, so that incorporates the school and the hotel, and we can change our brick style for that. So I simply select which brick I want and assign it to my selection. Now, for this individual face, I perhaps want to see what it looks like with stone. So I'm going to search for stone, select my stone material that I want, apply to my selection. Now, for this stone, I might need to map it. So I go over to my mapping material. I can change my X, Y, and Z scale, and even the rotation if I wanted to. Now for the lighting, I'm going to create a spotlight. I already have some Revit lights here, so I select where my spotlight should go and the direction. And Navisworks immediately calculates the light of that particular area. You see how the interface has changed now. The whole thing lightens up. I'm going to create another spotlight over here. And let's generate a point light. So with the point light, I don't need to give it a direction. I'm going to put that over the entrance here. And the whole interface adjusts with the new light source. I'm going to jump a little bit ahead a little bit here by creating the rest of the spotlights. And I'm going to turn off my glyphs so we see the lights themselves. And let's go to our environment, and we can change the color of the sun. I don't need to give it the location because everything was geo-referenced, and it already understands the lat and the long. So all I really have to do is just tell it the date and the time that I want the light for. I can have other settings. I can change my sun, my exposure, etc. And if I turn off my sun, then I see a nice little night view with the lights that I've generated. And now comes time to render this, and I can render it to the cloud, which is my preferred method because it's just so much faster. I can give it my cloud settings. It'll upload everything into the cloud, and shortly thereafter, I'll get a email stating that my rendering is complete. I can view my project, and I have two renderings here. This is for the interior of my school lobby and the exterior that I just sent up. And then I can save these as JPEG files. Or if I wanted to, I can also pick my interactive tracing, pick the time frame that I want to render it for. And once again, I can save this as an image to be brought into my project file. Okay. So there are more visualization tools that we have in the AEC collection. We can render within Revit, which will also allow us to render within the cloud. Civil 3D and AutoCAD can do some renderings as well, also rendering in the cloud. InfraWorks has some pretty nice rendering tools as well. All of these images that we generate, we can bring those into Sketchbook, and we can polish them up with Sketchbook quite nicely. Format has some nice rendering tools as well. And of course, 3D Studio Max is the granddaddy of them all. Okay, so I went through quite a few tools here, some old and some new tools. Last month I talked about the multi-line style. So the command for the multi-line style is mline, or the mline style actually creates you the multi-line, creating the styles for your multi-lines. Nice command. I think it's been forgotten. The solid command is pretty neat. The command for that is solid. And if we go way back to the trace command, the command for that is dot trace. So try out the dot trace command. It's pretty neat. And there's a grumpy old man. There's another grumpy old man. So I want to thank you very much for attending this session, and I apologize for the technical difficulties that we had. Visit us online, where we can have a variety of, these are the objects that we, the products we carry. We have e-learning bundles, we have some e-books, the instructor books, and these are a variety of ways of contacting us. So with that, I turn it back to you, Laurie.